Welcome, curious minds, to the deep dive. Ever stop and think about those unseen guardians behind so many products we rely on every day? The quiet heroes making sure our medicines are safe, our food's pure, and importantly, that the scientists creating them are protected too. It's this whole world of really meticulous systems behind the scenes, but totally fundamental. Today, we're diving deep into exactly that. We're exploring containment and fermentation and downstream processing. Now, that might sound technical, but it's really about preventing the release of biological agents, stuff that needs to be controlled. It's crucial for everything from pharma to food production, basically the silent sentinel of bioprocessing. And to help us navigate this, essential and pretty complex world, we are incredibly fortunate today. We have technologist Dr. Rama Yusufana with us. He's a senior lecturer from the Faculty of Engineering Technology at Tun Hussein on University of Malaysia, UTHM.
It's my pleasure to be here. Thanks for having me.
Our mission for you today: simple, give you a real shortcut to understanding what containment actually means, how it works in practice, and the rules that govern it while science moves forward. So let's unpack this. When we talk about containment in bioprocessing, it sounds like more than just keeping things locked up. Can you maybe break that down for us? What does it really mean?
That's a great place to start, yeah. Because containment is much more active than just, a box.
Mm-hmm.
Fundamentally, it's a whole set of measures, practices, all designed specifically to prevent the release of biological agents that could be harmful. So it's really about active control, vigilance. Think about maybe a lab working on a vaccine using a live weakened virus.
Mm-hmm.
If that virus isn't perfectly contained, even tiny invisible aerosols could escape.
Right.
That could contaminate the facility, maybe get outside, or even affect the staff working there. It's why every single step, from the seal tank, the bioreactor, all the way to the air filtering out of the building, it's all critical. It's about making sure that innovation, which is great, doesn't accidentally cause a problem.
Okay, so it's safety first, but also protecting the process itself.
Exactly. It's worker protection, definitely.
Yeah.
Public health, the environment, absolutely. But also, the integrity of the process, making sure the product itself is safe and pure. Because a containment failure doesn't just pose a safety risk. It could ruin an entire batch of product. That means huge costs, delays.
Yeah.
Maybe life-saving treatments don't get to patients on time, so the stakes are pretty high.
Makes total sense. So it sounds like you need multiple layers of defense then, not just one thing.
Precisely. Think of it like concentric circles of protection, each one backing up the others. We usually talk about three main types: primary, secondary, and tertiary containment.
Okay.
So primary containment, that's your immediate frontline defense, right at the source. Its job is to stop the biohazard escaping where it's being handled or grown. We're talking physical barriers. Things like the fermentation vessel, the bioreactor itself, designed as a sealed system, keeps the microbes in.
Like the tank itself.
Exactly. Or another great example, a biosafety cabinet.
Yeah.
The hood scientists work in. They create a controlled airflow, an enclosed space. Protects the person working and the lab area from any aerosols created when handling cultures. But, and this is crucial, these aren't just set and forget. They need constant upkeep, proper maintenance, regular checks, inspections. Absolutely essential. A tiny leak, a failing seal, it undermines the whole point.
Right, vigilance again. So what's the next layer out? Secondary.
That's right, secondary containment. This is your backup. It involves two main things: personal protective equipment, PPE, and really strict operational procedures.
Okay, PPE, like gloves, coats.
Exactly. Gloves, lab coats, maybe face shields, respirators sometimes. They form a direct barrier for the person, just in case that primary barrier isn't, 100% perfect for some reason. But it's not just the gear. The procedures are just as vital. Things like aseptic technique, working sterilely, proper hand washing, cleaning surfaces and equipment constantly, safe ways to dispose of waste.
Got it.
All these actions help maintain that controlled environment and stop anything potentially hazardous from spreading.
And the third layer, tertiary, that sounds like the whole building.
You got it. Tertiary containment is about the facility itself. The building's design, its systems, its operating procedures, all focused on preventing any biohazard from getting outside the lab environment entirely. Here you see things like specialized HVAC systems, heating, ventilation, air conditioning, but fitted with HEPA filters.
High-efficiency particulate air filter.
Precisely. They trap incredibly small particles, cleaning the air before it's recirculated or exhausted outside, keeps the air quality safe. You'll also have controlled access zones. Only authorized trained people can get in, often monitored with security systems. And you'll definitely find autoclaves, big ones.
For sterilizing.
Yes, using high-pressure steam to sterilize equipment, lab media, and especially waste before it leaves the facility, making sure nothing infectious gets out.
Okay, that layered approach makes a lot of sense.